All right, I'm going to go through and work out the problems of the third review. I also added a Google Doc there, so if you have specific questions, type in your questions to that Google Doc, and I will get back to you as soon as possible. If you want me to call you, put your phone number down and I will call you back. If you don't want to put it in a Google Doc, email me your phone number and I will call you back. All right, so the first one, we have to find where the cosine is -1/2. Well, cosine on the unit circle is our x coordinate, so I need to find out where our x coordinates are -1/2. And I just need to look at that a little bit more carefully. I was going to tell you the actual value. They're just asking which quadrant is it in. Well, this is quadrant 1, 2, 3, and 4. And there is a question like this on the test. This would be quadrants 2 and 3. Yeah, I know, I just switched from Roman numerals to standard numbers. Sorry about that. For sine, well, that sine is positive. Well, sine is positive right here and right there for your y coordinate. So that would be quadrants 1 and 2. And here, the tangent is negative. Well, it's going to be either a positive divided by a negative or a negative divided by a positive. Negative, positive, so it's going to be quadrant 2. And I have mixed signs in quadrant 4. So those are the quadrants that it would be in. Okay? All right, on here, first thing I noticed, I know we, especially in my class, we did everything in radians. This one's asking for degrees, so I just need to be careful and use the degrees on my unit circle instead of the radians. It's the same process. So on number 4, we've got 5 sine. Oh, and I hate when they have the 5 and the sine next to each other. 5 sine x plus 2 equals sine x. My s's and my 5's look too much alike. All right, well, first thing I notice on this, hey, I only have really one trig function. It's a sine. So I'm going to solve for that sine. So here, I'm going to subtract sine x from both sides. And you can think of that as 1 sine x. And that is going to give me 4 sine x plus 2 equals 0. Subtract 2. 4 sine x equals -2. Divide by 4. -2 divided by 4 is -1/2. So sine x equals -1/2. Now I'm going to look on my unit circle where my y coordinate is -1/2. It happens at 210 degrees. And it is going to happen at 330 degrees. Okay, so those are my two answers. And if I did it in radians, it would be 7 pi over 6 and 11 pi over 6. Let's go ahead and do the next one. So on number 5, that one's a little bit trickier. I see a secant, but we can handle that. So we're going to start with 5 equals secant squared plus 3. Apologize for my handwriting. I'm writing with a mouse. Again, I only have one trig function here, so I'm going to solve for that secant squared. Subtract 3, and you get 2 equals secant squared x. Well, to get rid of that square, I take the square root. Square root of 2 equals secant x. Well, I don't really want to deal with a secant, so I think to myself, what is the reciprocal of secant? Well, the reciprocal of secant is cosine. So I'm taking the reciprocal of the right-hand side right now and getting cosine. And then I ask myself, what is the reciprocal of radical 2? Well, it's 1 over radical 2. Well, then, of course, I would have to rationalize that fraction, and I'd get multiply that by radical 2 over radical 2. And I get radical 2 over 2 equals cosine x. Now I'm going to look on my unit circle for where my cosine is radical 2 over 2. It is right there. Oops, I meant to put my check mark over just a tad because I'm looking at my x coordinates. It is right there, and it is right there. So I'm going to say 45 degrees. And 315 degrees. I should put commas in between those. All right, let's go ahead and do number 6. So on number 6, I've got 7 cosine theta equals 5 cosine theta plus radical 3. I'm just going to go ahead and start by subtracting 5 cosine theta from both sides. So 7 cosine theta minus 5 cosine theta is going to give me 2 cosine theta. Sorry, I got a little bit lazy there and I don't want to write the original problem down again. And that's going to equal radical 3. Well, you divide by 2 and you're going to get cosine theta equals radical 3 over 2. I'm going to look at where my x coordinate is radical 3 over 2, right there. And right there. So that one looks like it'll be 30 degrees. And 330 degrees. All right, let's go ahead and do the last one on this page. We get a factor on this one. Cosine squared x minus 2 cosine x equals -1. First thing I notice is it's a quadratic. So I'm going to get everything set equal to 0. So cosine squared x minus 2 cosine x plus 1 equals 0. Now, I know some of you have a really hard time with factors. I'm going to kind of go through this 2 different ways. I'm going to do 2 sets of parentheses. What I'm doing is the opposite of FOILing. Cosine squared. I ask myself, how can I get cosine squared x? Well, that would be cosine x times cosine x. Then I'm asking what two numbers or what two terms would multiply to 1 and add to -2. That would be -1 and -1. And if I wanted to check that, that would be negative cosine x, add them together and you get -2 cosine x. Now take each factor, set it equal to 0. So cosine x equals 1. I'm only going to do this one. I guess I did that in my head. Cosine x minus 1 equals 1. Add 1 to both sides. I'm only going to do it one time because they're both exactly the same. So look on your unit circle where your x coordinate is 1. It's right here. And that is at 0 degrees. And if there was a line underneath that, we'd also include 360. But it says less than or equal to 0, less than 360. I'm sorry, greater than or equal to 0, less than 360. So I'm not going to include the 360. Okay. Let's go on to the next part. On here, it's the same type of thing, but this time we're solving and it is in radians. It's the same process, really. So if I looked at number 8, I'm going to start by adding 2 to both sides. Plus 2, plus 2. And that's going to give me 6 tangent squared. Oops, forgot my theta. Theta equals 6. Divide both sides by 6. Tangent theta my square equals 1. Take the square root. Tangent theta equals 1. Well, that needs to be where my y-coordinate over my x-coordinate is going to equal 1. It's positive, so it's going to happen in quadrants 1. So on this one, it's going to be pi over 4. I'm not going to write that down. I'm just going to say it. Pi over 4. And right here, because a negative divided by negative is positive. Anything divided by itself is positive. 5 pi over 4. Let's go ahead and do problem number 9. So on number 9, I'm going to go ahead and start by subtracting 9 from both sides. And that's going to give me sine squared x equals 1. Sorry if you just heard a dog moan in the background. That would be Ellie. Take the square root of both sides, and you're going to get sine x equals 1. Look for where my y-coordinate is 1. It's happening right here at pi over 2. Go ahead and do number 10. On number 10, I only have one trig function, cosecant. So I'm just going to go ahead and subtract minus 2 cosecant x from both sides. I'm not going to write it down because I don't have room. And when I do that, 3 cosecant x minus 2 cosecant x is just going to give me cosecant x. And that's going to equal radical 2. This is like the one that we just did on the previous page. Take the reciprocal of both sides. The reciprocal of cosecant is sine. So sine x is 1 over radical 2. You rationalize that, and you get radical 2 over 2. So I look for where my y-coordinate is radical 2 over 2, right here at pi over 4, and right here at 3 pi over 4. Let's go ahead and do the last one on this page. What I notice right away is it is a quadratic, so I need to subtract the sign to the other side of the equal sign and the 1. So I'm going to get 2 sine squared theta minus sine theta minus 1 equals 0. All right, so do my 2 sets of parentheses. Doing the opposite of FOILing. So I'm going to look at this first term. 2 sine squared. How can I multiply to get 2 sine squared? Well, it'd have to be 2 sine and sine. And then I'm going to look at my other term, my last term, L in FOIL. Negative 1. Well, my signs are going to have to be different. One's going to have to be positive and one's going to have to be negative. I'm going to make this one negative and this one positive. But I want to check my work really quick. That'd give me 1 sine, negative 2 sine, add them together and you get negative sine. So that is correct. Take each of those factors, set them equal to 0. So 2 sine theta minus 1 equals 0. Sine theta minus 1 equals 0. Solve each one, and here I'm going to get sine theta equals 1/2. Sine theta equals 1. Well, so I have to look where my y-coordinate is 1, right here at pi over 2. So that would be the answer right there. And then I need to look where my sine coordinate is 1/2, right here at pi over 6, and right here at 5 pi over 6. All right, these are the ones that get a little bit challenging. So find the angle whose sine is 0.61. Well, that's positive. It's sine and it is positive. So I'm going to have to draw that out, and I'm going to draw it out as 2 coordinates so that we can do each one separately, okay? So let's do this one in green. So I know it's going to be in quadrant 1 because that's where my y-coordinate is positive, and it would also be in quadrant 2. So what I am actually finding is this angle right here and that angle right there. So just to help out, remember that's going to be 0. This is pi. This is pi over 2. And this is 3 pi over 2. So I'm going to bring up my calculator to do the first one. And on this one, I've just did a Desmo Scientific calculator, just Googled it. If you don't have a calculator at home, just do that and it'll give you what you need. it started like this. I had to find the inverse trig functions by going to the function part and making sure that I was in radians, because first time I did it, I was not in radians. So I'm going to do the inverse sine of 0.61. My keyboard works on typing that out. And that gives me 0.65. So there's my first answer, 0.65. That also tells me my reference angle right here. So I'm going to have to take 3.14 minus 0.65. And again, that's just going to be calculator work. 3.14 minus 0.65. Actually, I probably should have rounded that to 0.66. Just notice that. And that's going to give me 2.484. So let's round that to 2.48. I'm going to round that to 6 as well. Oh, that's the worst 6 ever, but yeah, you can do it. On a test, I don't think I'd get too bent out of shape if you rounded something slightly off. That's not going to be a big deal. All right, let's go ahead and do problem number 13. So on that one, we're looking at tangent, and it's going to be tangent of 2.29. So that's positive. So it's going to be in this quadrant too, but it's also going to be in quadrant 4. So I'm just going to rearrange those. And the angles that I'm going to be getting are right here and right here. So on this, I'm going to go ahead and bring up my calculator again. And let's clear it out. Hey, Ellie, you got to be quiet. And I'm going to take the tangent inverse of, oh my gosh, I don't know if you can hear her. It's the most pathetic puppy ever. 2.29. And I get 1.159. I'm going to round that to 1.16. I think I got distracted by Ellie and realized I have a mistake here. So I will apologize right there, but that 1.16 is still good. I think I drew those in the wrong quadrant because it's positive. I drew them in the negative quadrants. It's going to be in quadrant 1 because a positive divided by a positive, and it would be in quadrant 3. So I apologize for that right there. And we all make mistakes. You just have to catch them. So right here is 1.16. That's going to be my first answer. And that's my reference angle right here is 1.16. So we're going to pi. And then we're adding that little bit on there. So that's going to be 3.14 plus 1.16. And I'm going to do this without a calculator. That's 10, carry the 1. 4.3. Comma in there. All right, so we got those two. I'll try not to make any more bonehead mistakes. I'm going to blame that on Ellie, who's over here crying. So let's go ahead and do problem number 14. On 14, we've got cosine, and it's negative. That means my x-coordinate needs to be negative. Well, x is negative in quadrants 2 and 3. All right, did that one correctly this time. So I need to be finding this angle and that angle. So I'm going to bring up my handy dandy scientific calculator and do the inverse cosine of negative 0.55. And I get 2.15. Oops, I'm still in red. That's okay. So that would be this one right here. 2.15. And that makes sense. It's going to be bigger than 1.57. So I need to know what this little reference angle is right here. That little reference angle is just going to be 3.14 minus 2.15, and that gives me 0.99. That means this reference angle here is 0.99. So 3.14 plus 1.9, or try that again, 0.99. Again, I apologize for the handwriting. Is going to be 4.13. All right. So I'm actually going to leave number 15 off. It's a cosecant. Cosecant is really not going to, yeah, we can go ahead and do it since I'm going to talk about it. Cosecant, you need to ask yourself, who's the reciprocal of cosecant? Well, it's sine. So what you could do is just take the reciprocal here. So that would be sine theta, and then take the reciprocal of negative 1 over 20. That's not a big deal. So that would be in quadrant 3 and 4, because that's where my signs are negative. So I would have to find this angle right here and that angle right there. So let's go ahead and put this in our calculator and see what we get. So inverse sine of negative 1 divided by 20. And I get negative 0.05. Well, I want to solve this between 0 and 2 pi. So what they're actually giving me right here is this right here, 0.05. And I'm just going counterclockwise. I'm sorry, I'm going clockwise because it's a negative. So just take 3.14 minus 0.05. Oh my gosh, I'm making tons of mistakes. Did I say 3.14? No, don't be ridiculous. It'd be 6.28 because it's 2 pi right here, minus 0.05, and you get 6.23. So there is my first angle. Well, my reference angle here is going to be 0.05. Go ahead and add that to pi, and you're going to get 3.19. All right, let's see, where are we at? What's the next question? All right, tell you what, I'm going to make this into 2 videos because this part's going to get a little bit longer as well. So here is the end of video part 1, and I will have the second part of this video posted later today. Enjoy.